In this next projectiles example, we have not been given the speed. We've been given the angle as a relationship with tan theta. So we're told the angle of elevation is theta and tan theta is 4/3. And this time we're not on a horizontal plane, we're 42.5 meters above a horizontal plane. So let's again draw ourselves a little diagram of what's happening. So we're starting 42.5 meters above the ground, and then let's put in a horizontal bit there. So we've got initial speed of v meters per second and our angle theta. Now we want to draw a little right angle triangle to show this relationship. Tan is opposite over adjacent. So if we put theta there, the opposite would be 4 and the adjacent would be 3. This gives us a Pythagorean triple, so the hypotenuse is 5. So then we can do sine theta is opposite over hypotenuse, 4/5, and cos theta is adjacent over hypotenuse, 3/5. So if we have to use sine theta or cos theta in our questions, we know we can substitute in these values. Then question A says show that v equals 20. Okay, so we want to find this initial speed. So we know that it takes 5 seconds for it to hit point A. So we're going to resolve vertically and put in all the things that we know to get to point A. So the vertical displacement is minus 42.5 meters. Our initial vertical velocity is v sine theta. We don't have and don't want our final velocity. Our acceleration is due to gravity, 9.8, and our time is 5 seconds. So our Subat equation that doesn't have v in it is s equals ut plus a half at squared, and sub in all of our values. So minus 42.5 equals u, well, we know sine theta is 4/5, so we've got 4/5 v times t, so times 5, minus 4.9 times 5 squared. So minus 42.5 equals 4/5 times 5 is 4, so 4v minus 4.9 times 5 squared, which is 122.5. Let's add that to the other side. So we get 4v equals 80, and therefore v equals 20 as required. Part B, find the distance OA. Find the distance, so we're actually trying to find this length across here. Now we know the vertical part, so if we want to find this length, we can make that a right angle triangle. We need to find this horizontal distance, and then we can use Pythagoras. So let's resolve horizontally. We're trying to find the horizontal displacement. Our initial horizontal velocity is v cos theta. We know v is 20 and we know cos theta is 3/5, so we know that value. Our final velocity will be the same. Our acceleration is 0, and we know our time is 5 seconds. So using s equals ut plus a half at squared, we get s equals 20 times 3/5 times 5. So that is 60. So then to find OA, we're going to do the square root of 60 squared plus 42.5 squared, which is 73.5, so therefore 74 meters, correct to two significant figures.